good morning and good afternoon. It depends on where you are. Welcome to another edition of this amazing distance learning journey. We're here with the Scientists in Action in partnership with the Denver Museum of Nature and Science, as well as FreshWaterLIVE, a partnership with the Prince William Network and the U.S. Forest Service. My name is M. Chad Edwards. I'm happy to be your host for the day. I am an education specialist with the United States Forest Service. We have lots of other support. Remember, you are the real stars. You folks watching at home and in your classroom, you're the real stars. We hope that you're ready to have some fun, because in the education world, we like to think of fun as what you feel when you learn something new or applicable to your life. So be ready for that. We need your participation. We need you to speak up loud and clear when it's time to come to your classes. We've done a number of checks, so we know that you're out there and we're ready for you. When we are fully ready for you, we'll unmute you so we can hear you. Until then, please stay on mute. It's going to help everything to flow nice and smooth. All right? Let's see. I'll even give you heads up before you come, and we'll take some questions there. If you can't wait any longer and you want to get your question out immediately, pop it into the chat. That's always available to you. If you have any technical difficulties, pop that in the chat. We're happy to get to those as well. We have scientists here with us, and we also have scientists off screen. So thank you to Joan Carlson. She's a hydrologist with the U.S. Forest Service. She'll be answering some of those things for you immediately for that instant gratification factor. And then I'll introduce you to our scientists here on screen in just a moment. But I want you to know that this is Freshwater Live 2. It's a bit different from the first. Without taking away too much of the story, I want you to know that we're still going to go from forest to faucet. That story still exists. But out here in the West, it's pretty different from out east. It's a lot drier here. Back in the West, back in the East, where I'm from, every time I sniff in, I'm almost taking a sip. It's so much moisture out there. Here, it's a little bit different. The altitude here, we're in much higher land than back in DC or on the East Coast, where we were in the Catskills for our first episode. And I'll tell you something about this high land up here. I'm not going to spoil it all the way, but these mountains out west, they're actually big enough to make water fall from the sky. They actually create weather. That's kind of blowing my mind, because now that I know our mountains are just hills. I'm going to introduce you to the scientists who will be answering your questions here on screen, because they're rock stars and they go with the flow. We have both a hydrologist and a geologist, so that's the rock and flow. Bob and Carl, please take it away. I'm going to jump off screen. You might be able to hear me later. You are stars, please.
Okay, I'm Bob Reynolds. I'm a research associate at the Denver Museum of Nature and Science in Denver, and I am a geologist. I study rocks.
I'm Carl Chambers. I'm the forest hydrologist for the Arapahoe and Roosevelt National Forest and Pawnee National Grasslands in central Colorado, and I study water. So we're standing here on the shores of Grand Lake. You can actually see the lake right behind us, and Grand Lake is at the very close to the headwaters of the Colorado River watershed. In fact, you can see the Continental Divide right behind us. The top of the mountains are the Continental Divide. And the Continental Divide is a big ridge that runs clear down through North America. It starts up in Canada, runs down through Montana, Wyoming, Colorado, New Mexico, on down through Mexico, and on down through Central America. And it essentially divides where the water ends up. All of the water that falls west of the Continental Divide eventually ends up in the Pacific Ocean. And all of the water that falls east of the Continental Divide eventually ends up either in the Gulf of Mexico or in the Atlantic Ocean. Now, I said that we were close to the top of the watershed. A watershed is just the area that all of the precipitation that falls on that land area drains to a central point. And so there's kind of two things about the watersheds. First of all, the water flows downhill, so it concentrates as it goes downhill and flows to a central point. And there are also the fact that small watersheds nest in bigger watersheds, which nest in even bigger watersheds. So that we're standing kind of at the confluence of two small watersheds, North and South Inlet. Those are the two valleys in the mountain behind me. And they contribute flow directly to Grand Lake and kind of make up the watershed right at this point. But we're also standing in the watershed of the Upper Colorado River, which runs clear down to the confluence with the Green River, and the Colorado and the Green are the two big rivers that make up the Colorado River watershed. And we're also standing in the larger Colorado watershed that runs clear to the Pacific Ocean. So we're going to have a poll here for just a minute, and we're going to ask you all to take the poll and tell us where the water that goes past your house or your school, where does it end up?
So it seems like for many of you, the water ends up in the Gulf of Mexico. Others, I see it ends up in the Atlantic Ocean. And then quite a few of you, your water ends up in the Pacific. So your water is going in many different directions. And that is a metaphor for Colorado. Colorado is a headwaters state. If you think about it, we have the Rocky Mountains behind us. Some of these mountains are some of the highest mountains in the lower 48 of the United States. And the water comes as snow, largely falls on those mountaintops, and then it flows out of the state of Colorado in all. We have water that flows to the south, and the majority of our water flows to the west in the Colorado River system. So this is an area where the water is arriving, and then we are sharing the water with the rest of the people in the United States. And in fact, here we're at the headwaters of the Colorado River system. This river that's going to leave Grand Lake is going to flow down through the deserts of the southwestern United States, through Utah, parts of Arizona, parts of Nevada, all the way down through Southern California, and eventually into the Baja California area where it flows into the Sea of Cortez. So these waters that you see here are being shared with people all around us. We want to take a moment for you guys in your classrooms to think about where your water comes from. So we talked about where your water goes to, but where does your water come from? Take a moment and just chat with your neighbor. Where does your water come from? So I hope many of you thought about that question and you think about where your water is coming from. A lot of you probably answered that your water is coming from uphill, it's coming from mountains, it's coming from headwaters systems like Carl talked about from the Continental Divide near where you are. And here in Colorado, we have a variety of ways that we move water around because the water is coming from the mountains, but the people live out on the plains. We're farming out on the plains, and we have a wonderful variety of technologies that we use to move the water. We move the water through pipelines, we move the water through irrigation ditches, and most spectacularly, we move the water through tunnel systems. And just behind me here, at the head of Grand Lake, there's a tunnel that goes over 10 miles carrying the water here from Grand Lake over across underneath the Continental Divide to the city of Denver, where the people are drinking the water. Our drinking water where I live in Denver, the drinking water that I drink has been moved through this tunnel system underneath the Continental Divide, allowing us to drink fresh water in the Denver area. So one of the things that we need to think about is how we're moving the water. And wherever you are in your schools and your homes, there's been a tremendous amount of work that's gone into engineering the systems to move fresh, clean drinking water to your water faucet. When you turn on that water faucet, you should think about where does that water come from and how does it get to you. So I'm going to turn it over to Carl here, and he'll talk about how the mountain systems and the forests are providing you with some of your water.
The national forests manage a lot of the mountainous areas in the West, and that turns out to be an important part of the water picture because of what mountains do to weather. As air masses and clouds approach mountains, they make the air lift up over the top, and as that air cools, it can't hold as much water, and it actually forces the water out of the clouds as rain or snow. Now, in much of the West, where in the winter that water falls as snow and it's stored in the mountains during the winter, and then slowly begins to melt out during snowmelt runoff. and runs downhill out of the mountains and runs through the forest. But it doesn't necessarily run over the forest floor. It runs through the forest floor, which is made up of soil, organic matter, litter, duff, other materials on the floor. And it's that forest floor kind of serves as a big sponge and filter. It soaks up the water, it holds it, it releases it slowly, and it actually cleans it on the way to the stream channel. Seems kind of odd that water running through soil would be cleaned, but that's really how it happens. As long as the water is moving slowly and the soil is staying in place. That system of the water being stored in the winter in the mountains as snow and then coming off as runoff during the spring and the summer is kind of an important part of how we use water. It kind of creates a natural reservoir. And we depend on that system for the water that we use, both the water that we drink, the water that we use for irrigation, the water we use to wash our clothes and brush our teeth and all of that. It's also important to recognize that there's an aquatic ecosystem out there that is equally dependent upon the water as we are. There are plants and animals and fish and bugs that all need the same sort of reliable and clean water supply that we do. And one of the things that the National Forest does is we try to make sure that there's enough water for both, that we provide water both for human uses as well as making sure that there's enough water left to maintain healthy aquatic ecosystems.
Thank you so much for sharing that with us, Carl. So I'd like to go to some of the classrooms that are sitting out there waiting to ask you questions. So how about we start in Georgia, and then we're going to go to Indiana, and then we'll jump over to Alaska. We'll do 2 questions from each. Okay, so let's start at St. Luke School, while Mount Tabor Elementary. You can go ahead and get ready because we're going to come to you next. Let's start. St. Luke.
What caused you to enter your field of study?
Well, I'll take that first, and then Carl can answer. So I'm a geologist, and I love to do science, and I like to do science outside. So being a geologist lets me travel around the world, lets me do science, and lets me be outside doing my science.
I think water is so important both for our uses and for the ecosystems that it's just really interesting for me to be a part of managing the water on the national forests.
Great. How about a second question from you all at St. Luke School? We're ready for you.
Why is there more water in the mountains?
Because kind of what I was talking about earlier, because the mountains actually change the weather, they make more rain and snow fall in the mountains. Also because the mountains are colder, particularly in the winter, rather than evaporating or running off, much of that snow is stored during the winter months, and then it becomes available during the summer.
And you can think about it also as the moist air that's coming off of the oceans. As the wind moves that moist air, it carries it towards the mountains where it then gets cooler, as Carl's mentioning. And as that moist air gets cooler, it precipitates or it rains or snows. And that's why the bulk of the water is concentrated in the high mountains.
All right, excellent. Thank you so much for those explanations. We're going to jump from Georgia to Indiana. Mount Tabor Elementary, you all ready for us? We're going to take 2 questions.
Ellie, go.
How does nature
I couldn't hear that question. Can you repeat it?
How does nature filter water to make? How does nature filter?
Okay. Well, I was talking about the importance of the forest floor. There's a bunch of material out sitting on the ground on the forest. There's dead and live plants. There's decaying organic material, and there's also the soil itself. Now, all those things may seem kind of yucky, but they really serve to provide a sponge that soaks up the water and holds it in the forest and slowly releases it, and as a filter to clean the water as it's traveling downhill toward the streams.
Ooh, do you all have a second question ready for us, Mount Tabor?
How much fresh water?
How much fresh water do you take? How much fresh water per day?
That's a good question. It's kind of a complicated question too, because you have to think about what you mean by need. We probably drink maybe a little less than a gallon of water a day, but think of all the other water that you use. Do you water your lawn? Do you use water to brush your teeth and run the dishwasher and wash your clothes? And all of those things. On average in the West, we use about a half an acre foot of water a year. So if you imagine a football field filled 6 inches deep with water, that's about how much water your family uses.
Another thing just to think about it is that there's water being used to provide, for example, the cloth that you're wearing. If you're wearing blue jeans, the blue jeans are made of cotton. The cotton is grown with water. When you think about the meals that you're eating, the bread is made from grain, the meat is made from beef. That all requires water. So there's water being used in many different ways every day by all of us.
Great. Classrooms. Thank you so much. We will go back into classrooms in a moment. So would the Toke School go ahead and get ready? But I'm going to take a few questions from our online audience. Remember that we're on Facebook, YouTube, and even FreshWaterLIVE.org is where you can ask questions. The first one coming from online is from a teacher/naturalist in Virginia. And that's Mary. She's asking, are stream restorations successful?
Like everything else, some of them. I think that we haven't been thinking about restoring streams for very long in the bigger scheme of things. We've probably only actively been doing it for the last 20 or 25 years. And I think that just like everything else, we're getting better at it as we go. So I think that, yes, largely stream restorations are successful. I think that sometimes because the problems show up in the streams, we think that the solutions are in the streams. And sometimes we need to take a step back and look at what's going on in the watersheds and think if there are restoration activities that can happen in those watersheds that will make the streams healthier.
Ooh, thank you. We're going to jump from Virginia and go to South Carolina. We have Mrs. McLean's class. The question is, how long does it take to clean the water? And what kind of germs are there in water?
Well, we've been cleaning up the water around us since I've been living, watching it. I've looked at river systems that started out when I was a young child. They were polluted. There were no fish living in them. And we've cleaned up those river systems tremendously, and it's happening on a worldwide basis. There's a wide variety of pollutants that can get into water. It used to be rivers were thought of as places where you could just dump your garbage, throw your waste. Today, through education, we've learned that the river systems are vital to the health of all of us and that we want to share that water regionally. So we've cleaned up the rivers. We've taken the garbage out of the rivers in Colorado. We've had volunteers, students have gone to the rivers. They've cleaned up the rivers. We've had scientists looking at how the water flows into the rivers. We've cleaned up the chemical pollutants and the biological pollutants that are in the waters flowing into the streams. In many communities, you'll see there's signs that tell you, that warn you not to pollute the river systems, not to pour waste on the ground that's going to flow into the rivers. We're cleaning up the rivers worldwide, and wherever you go, the water is getting cleaner.
Great. I'll take one more online question. This one's coming all the way from California. What's the best way to capture fresh water in a drought-stricken area?
Well, for example, the area right behind us is a reservoir. We store water. The water arrives when the snow melts in the spring, and we store the water in reservoir systems so that we can use it year-round. So one of the best ways that we have to store water is in reservoir systems. And for those of you in California, we store the Colorado River system, for example, in Lakes Powell and Lake Mead. Those are big reservoirs that influence the storage of Colorado River water, some of which goes to California.
Great, thanks. Hey, let's go on all the way up to Alaska. How about Toke School? Are you all ready? Let's get two questions from you all up there.
Okay. ready. Go ahead, stand up there. Peek into it. See, Bella.
What is aquatic?
What's the newest aquatic creature you found? What's the newest aquatic creature you found?
Oh, there's
Repeat the question.
the question is, what is the newest aquatic creature that we've found? We just recently found a very rare little stonefly called the Arapaho snowfly that lives only in a few streams along the Front Range of Colorado. And it's got a really funky life cycle. It spends most of its life living under the snowpack, and for much of the summer, when we could find it, it actually drills down and lives in the wetted soils around the stream, which is probably one of the reasons that it's been hanging around for a long time, and we only recently found out that it was there.
I love it. So science is still uncovering new things every day. Thank you, Toke School. How about another question from you guys?
What else can pollute water?
What else can pollute water?
What else can
Pollute the water.
Oh, so what else can pollute the water? Well, a lot of the pollutions that come into water come from the activities of man. If you think about the things that we do on a day-to-day basis, we have a variety of ways that we can inadvertently make the water polluted. One of them, for example, is if we don't pay attention to where our sewerage goes. And around the world, we're paying more and more attention to wastewater, the water that leaves the home. After you take a shower, you flush a toilet, where does that water go? And that water goes, in many cases, to waste treatment plants where they clean the water up so that it can be allowed to go back into the stream systems and be reused by other people as well as by the natural environment.
All right. So I'm again encouraging everybody that if you have questions and we're not getting to you fast enough, go ahead and pop those questions into the chat. We're happy to take them there. We're going to stay with Alaska for a minute and go to the North Star School. Go ahead and get yourself situated. Speak nice and loud and clear. We'll take 2 questions from you guys. You look great, and we're ready to hear from you also.
Yeah.
We ran out of fresh water. Could we run out of fresh water?
So the question was, could we run out of fresh water? And there's a limited amount of fresh water on the Earth's surface, but we share that water and we reuse the water. So it's unlikely that we're going to run out of water, but the water is not evenly distributed across the surface of the Earth. And down here in the lower 48, we've got to be concerned because many of the people live in drier areas. For example, we've got a lot of people living in Arizona, in Nevada, Southern California, areas where there's not a lot of fresh water locally available. And we actually share the water from Colorado with people living in those areas. And so if we can share it carefully and be conscientious with how we use it, there's plenty of fresh water for everybody.
Great. How about a second question there from North Star? We are ready for you.
Yeah. How can we prevent animals from polluting the water?
How can we prevent animals from polluting the water?
The hunter.
I don't really think of animals as polluting the water too much. Now, I think that sometimes there are things that occur in water naturally that can become problems if there's too much of it. So that, for instance, in where I live in Fort Collins, Colorado, on the other side of the mountains that are behind us, we have lots and lots of geese in the that stay there in the winter, and the geese poop in the water. And that can become a problem locally, but that's what geese do. So it's not so much that we have to stop the geese from doing it. It's just that there may be too many geese at a particular place that we have to think about that as a potential source of pollutants.
Amazing. Our questions have come from Georgia all the way up to Alaska. I'm not exactly sure where this next one comes from, but it's a great one. With icebergs melting, are you getting good water from them?
Well, the icebergs are melting at sea, and so there is fresh water that comes from those icebergs, but we do not use the water from melting icebergs. So The majority of the water that we're using is surface flowing water, fresh water that flows in rivers and streams, and we find it in lakes and reservoirs.
Great. Folks at home, in your classrooms, go ahead and keep coming up with questions. I think we'll have enough time to come back to you again. So keep these questions coming. We'll take another one from the chat, though. This one is, can we use solar energy to desalinate water? This one has come up a number of times. I want to make sure that we hear it from you all.
Yes, so we do use solar energy to desalinate water. The desalination of water, which is taking salt out of salty, brackish water or ocean water, involves a lot of energy. And there are many parts of the world where we're experimenting with desalination, taking the salt out of the water, and that energy is derived from wind turbines, solar panels, as well as from natural gas, oil. So we use a lot of energy to desalinate water, and depending on where you are, different kinds of energy are available. I'll just give you one example. For example, in Western Australia, there's a water shortage in the town of Perth, and they're using wind turbines. So they're using the energy from the wind to run the desalination plants in Western Australia right now.
Ooh, thank you. So, hey, Carl, as I'm looking around, I see that there's lots and lots of beautiful trees surrounding this body of water. I'm also noticing that there are a lot of dead trees in there. Can you kind of explain to us what we might be looking at in this piece of the forest?
There are a lot of dead trees up there. There are two little bugs, the mountain pine beetle and the spruce beetle, that have killed really millions of trees all through the Rocky Mountain West. And, it's hard for us to imagine that forests change because trees live for so long that the forests kind of remain the same for long periods of time. But there are disturbances that happen to the forest, and the beetles were one of those. Now, the beetles have been around for a long time, and there have been outbreaks of beetles in the past, but we had never seen an outbreak on nearly the scale that had happened as it has happened recently. And there were real concerns about how that was going to change processes and conditions in the forest, including with water. The scientists have been studying that question for about 10 or 15 years, and it turns out that while there are changes, the changes are subtle, and a lot of the concerns were probably, it turned out that they weren't as big a deal as we initially thought they might be. Some of the questions or some of the changes are that the water melts out a little quicker from under stands that have a lot of dead trees because there's more sunlight. And there may be a few more nutrients in the water exiting the watersheds because the plants aren't using, particularly the trees are not using as many of those nutrients. But those changes and the processes are subtle and hard to measure. Now, there are some other disturbances that happen in national forests that are a lot bigger deal for water, and one of those is wildfire. When fire burns up a watershed, it burns not only the trees, but it burns that forest floor, that sponge and filter that I've talked about before. And so when it rains on an area after a wildfire, on a burned area, things change a lot. There's a lot of erosion. There's a lot of sedimentation. The water is running off very rapidly over the surface rather than through the forest floor. So there can be flooding and debris flows, and there's a lot of muddy water getting to the stream channels all at the same time. This can be a real problem for people like the municipal water providers who are responsible for cleaning up the water that we use to drink and for other uses in our houses. And sometimes the water can get so muddy that it just doesn't work for them, and they have to find an alternate water supply until the forest starts to recover. The Forest Service does a number of things to try to manage wildfires. Wildfires are a natural part of the systems, but certainly hot and big wildfires can cause a lot of problems. So we thin forests and cut trees to try to see whether we can make the wildfires smaller and maybe not as hot when they occur. We certainly fight fires when they do happen. And then following fires, we'll go up and take a look at those burned areas and see if there are some things that we can do to help in the recovery. One of the things that we do quite a bit of is actually dropping mulch out of helicopters, straw, agricultural straw, or wood firers that we drop onto the burned areas to start replenishing the material on that forest floor and to start giving something that will start slowing the water and keeping it on those slopes rather than rushing to the stream channels.
Very interesting to hear that you're using forest products to help the forest recover. That's fascinating stuff. Let's do a lightning round of all of our classrooms again. Let's do one question from each of our classrooms. So go ahead and get yourselves ready. We're going to come to you quick, loud and clear. How about Georgia, St. Luke's School? We're ready.
How much water does snow produce annually?
Oof. How much water does snow produce annually? It's a very good question, but a difficult question to actually measure in very quantitative terms. But in Colorado, for example, the majority of our water that comes from the air comes as snow in the wintertime. And that snow gradually melts to provide us with our water supply. And if you wanted to get numbers, you could look, for example, at the flow rates of the river systems that are leaving Colorado, and the majority of that water would have come as snow. So if you want to get some numbers, you could actually go to the computer, and you guys could go to the internet, and you could find out how much, for example, how much water is leaving Colorado in those river systems, and you could make the assumption that somewhere between 60–70% of that water came as snow and is now leaving Colorado as water.
Fascinating. Mount Tabor Elementary, are you all ready?
Go ahead.
We can see you and we're ready to hear you.
Mount Tabor, I'm not sure that your mic is on because we saw you talking, but we couldn't hear what you had to say. So can you repeat your question?
Is there more fresh water in the world above ground or underground?
Okay, so the question was, is there more fresh water in the world above ground or underground? And the answer is most of it's actually underground. So the fresh water of the world is a very small proportion. Most of the water is salty water. And our water supplies we use are the waters that we can find on the surface. And it's only a small proportion. If you think of all the world's water, if you put it all in a gallon jug, just to think about it in that way, there's only 3 little Dixie cups that are fresh. Most of the water is salty. And of the 3 Dixie cups, actually 2 of them are frozen. So 2 are filled with ice cubes. There's only 1 Dixie cup that is the fresh water that is liquid on the Earth's surface. And the vast majority of that fresh water that is liquid on the Earth's surface is actually in the Earth as groundwater. And only a small proportion of that is available on the surface. And if you think about it, it's only the size of an M&M is the surface water. So we're relying on that little tiny bit of fresh water that's on the surface for the vast majority of our drinking water.
Great. So we'll take a quick one from online. So we've got our friends in Alaska. Students are wondering that since we have so much water in Alaska, especially Kodiak, is there any way we could share it with places that don't have enough water?
You know, they've thought about that. One of the hard things about moving water from Alaska is that it's a long ways away, and water is really heavy, and it's kind of expensive to move. We do move water long distances, but we haven't moved it quite as far as you guys are talking about yet right now. But there are certainly pipelines in Colorado that move water through a series of pipelines and ditches hundreds of miles. There are also those similar sort of pipelines and ditches and other infrastructure in California that moves water hundreds of miles. We haven't gotten to the point of moving the water thousands of miles from Alaska down here, though. But thank you for thinking it up.
Great. Let's take one more from online before we go to classrooms. So how about from Emily in Montana? Does a watershed ever end before it goes into the ocean?
Ultimately, no. I mean, you can talk about smaller watersheds that end at a point that might be of interest to you for one reason or another within that watershed. It may be the water that drains into a lake. It may be the watershed above the intake that your town uses for water. But that water does continue to flow downstream, and it is in a watershed until it gets to an ocean.
Great. Let's go to a classroom. How about Toke School? We're doing the lightning round. So one question, we'd love to get that from you, and then we'll go to North Star. Right now, Toke.
How many animals die from polluted water?
How many animals die from polluted water?
Goodness me, how many animals die from polluted water? Well, I think you might, if you think about it on a worldwide basis, I'm sorry to tell you that people die from polluted water. And so one of the things that we're concerned about as scientists studying water and water resources is how to keep enough water clean on a worldwide basis so that less people get sick from it. And I think in the natural world, animals are pretty resilient for the most part. And there are cases where if we pollute a river, the fish will die. There are cases where if the water gets too polluted, some of the animals that drink it will die. But we've been making big efforts to clean up those river systems on a worldwide basis. And I think a lot of people are spending time now looking at how to keep the water clean for people.
Great. Lightning round style. North Star, we are ready for you.
Yay!
Yes, indeed. Yay.
How does water get to the ocean after we use it?
Well, water flows downhill. So after you use it, it depends on how you're using it. But typically in a city, what happens with the water is that it will flow through pipes out of your house, out of your school, and it will go to a water treatment facility where they'll clean up the water. And then it typically goes back into a river, and that river then continues downstream. Now, you know, if you think about really big river basins like the size of the Mississippi, if you're at the top of the watershed, the water flows out of your house, goes to a water treatment plant, and back into the stream. But if you're farther down, you may be using that water again. And so the water can get used many, many times. It's taken out of the stream, it runs back into the stream, and eventually we continue to use it until it gets to the ocean.
It's like the water cycle is the original recycling. That's pretty cool. Thanks for explaining it in that way. Got a question online here, and it is how it's coming from Marianne in Virginia. How are people going to share a dwindling supply of water?
Well, Marianne, that's of course a super question, and it's a worldwide question. And one of the themes that we'll talk about here is we've talked about caring for water, and we talk about sharing water. And we do share water worldwide. And I've traveled a lot around the world, and I work in Africa, I've worked in Asia a lot, I've worked in the Middle East. And wherever I go, people are sharing water. Everybody needs water. Everybody needs clean, fresh water. And water is a resource that is finite, is limited, needs to be cared for, and it needs to be shared. And we have a wide variety of organizations. We have rules, we have systems that encourage us to share water equitably. So that is a challenge, though, in many parts of the world. And it continues to be a challenge, and you'll be reading about it in the news.
So we have one more from online. We'll take fracking, the extraction of coal and things from in the ground. How does that affect our fresh water?
You know, it kind of depends. And some of it depends on the relationship of where the hydrocarbons are to where the water sources are. In some places, they're fairly close. You know, the strata that bear the water and the strata that bear the hydrocarbons are pretty close, and you have to be very careful with the fracking so as not to interfere with those groundwater supplies. In other places, such as in eastern Colorado, where on the Pawnee National Grassland, one of the areas where I work, the hydrocarbons are at thousands of feet of depth, and the water is usually at less than 1,000 feet of depth. So there's 6,000 feet of rock separating the fracked hydrocarbons from the water. So there's quite a bit of protection left there.
Great. How about any final thoughts that you all might have, Bob and Carl? I mean, you're experts.
Well, I think, again, I'm going to underline the fact that there's a limited amount of fresh water on the Earth's surface, and we need to be careful of it. We need to care for it. And then there's a limited amount of water on the Earth's surface, so we need to share it. So that concept of caring for it and sharing it really run through the whole water system. And the people that are responsible for taking care of it are scientists. They're scientists like geologists like myself. They're hydrologists like Carl. They're foresters. There's a wide variety of scientists that get involved with caring for and ensuring that we share water carefully. And you students are going to find that there are wonderful opportunities in careers as you go forward. Those of you who take science classes or are interested in science, you can become the scientists of the future that take care of our water supplies. And we need you to take those science classes so that you can take care of the water for the people in the future.
I would just echo what Bob said. We do have enough water to go around, but we do need to share it, and we do need to use it carefully and not waste it. And we also need to leave enough water behind so that there's enough water to support the healthy ecosystems.
Great. Let's take a poll question. This will be our final poll question before we close out. What will you do to protect water in your hometown? All right, let's just give you a quick moment to do that poll, and we'll look at the results here on the screen. I'll tap that on my screen. Let's see. So the majority of us are saying that we're going to be smart about how we use water. Thank you so much for that. If I can just encourage you all, because you are clearly geniuses, clearly. We can tell from the questions that you're asking. You're looking at things with fresh eyes, and that's going to help keep us sharp, and it's also going to help you to figure out even new and advanced ways that we may have never even thought of before. So use all that creative genius that you have to help people who live downstream, because really, we all live downstream from somebody. So if I can encourage you to come back and join us for our other episodes, we have a Scientist in Action coming up on October 26th. That's all about ancient mummies, new discoveries. And then we have, just like this is Freshwater Live, we'll be doing Caves Live. There's a water story in that as well. That's coming up on March 14th of 2018. And you can see that one at caveslive.org for more information. Thank you so much for joining us. Thank you for your questions. Thank you, Carl and Bob. Thank you, Joan. Thank you to all of our classrooms out there. Yes. See you next time.
Thanks. Bye.
Bye. Bye.